5, 5.
Hi,
Hi, Deborah. How are you?
okie dokie.
Nice.
How are you?
Doing well.
New Jersey still?
Actually, today I'm in Maine.
Excellent. Where in Maine?
We're visiting Acadia National Park.
Oh, very nice. Lots of lobster.
Oh yeah, definitely.
Yeah.
Here's Stuart.
I'm just going to bring my cushion stuff in from outside since it looks like possible rain.
Sounds good. How are you, Stuart?
Good. How you doing, Ryan?
Pretty good.
Still hot in New Jersey?
Yeah, it was oppressive the last few days, but we got away to Maine, and right now we're in Acadia National Park. We're staying here for a few days.
I'm sure that's very beautiful.
Oh yeah, it's spectacular. I love it.
Oh, you've
First
been
time
there
here.
before, huh?
No, this is my first time in Maine.
Mm-hmm. Well, that's great. Yeah, I've always wanted to go there. Yeah, I've heard it's just very beautiful.
Yeah, definitely. We got a lot of hikes planned over the next couple days.
Does it seem very crowded?
Not too bad. There's a few people here, but it's not anything crazy.
Stuart, were you ever there?
No. Have you ever been there?
Through it.
Mhm.
I think you go there to catch the ferry up to Nova Scotia.
Yeah. Right. Not in the park, right?
We're like
It's-
just outside of it. We're sitting on the harbor pretty much.
That's where the ferry would go to Nova Scotia?
Yes. Mm-hmm.
Mm-hmm.
Yeah.
Good. Well,
Let's
enjoy.
see. Yeah. Yeah. So,
Right.
how's-
So is Owen joining us?
I think she might come later. She just like she
Okay.
only saw the second half of the movie, but it was very easy to catch her up on the plot line.
Sounds good.
Mm.
Yeah. So this week's film was.
I thought 3022. Wasn't until the end that I went, duh. That is not the year 3022. I mean,
right.
Right.
Well, in fact, he went looking for his girl
Mhm.
on June 9th.
Mhm.
When it finally says at the end that 3022 is day number, it also says the date, and it
June
was June 9th.
Wow, look at that.
That's
Yeah.
funny.
Yeah. And I'm looking at it, 15 minutes to go at on June 8th until June 9th. So yeah. Anyway.
Where do you want to start?
Yeah. What I wanted to do was, let me just share the screen first. It's more organized. Okay. So here is our presentation, and the movie starts off, and they're en route on their space station Pangea, and everybody's doing fine like mentally, but as the years go on, it gets really, really hard to remain cool, in the head. And it got me thinking, there's a lot of psychological obstacles that need to be overcome if we're going to plan missions to other planets, and if not other stars. For example, going to Mars, how do we sustain a crew psychologically on a trip that could last months? And if you're in a spacecraft with a dozen other people and you're just seeing them in this closed environment for hundreds of days in a row, and no outside communication, or I should say no outside interaction with other human beings, that really
And
takes
no hibernation.
Yeah. And yeah, it's not like these other sci-fi films where you can just like freeze yourself and wake up centuries later. This is the real world we're talking about now, especially if we're thinking about going to Mars soon. We need to have a crew in that spacecraft for several months at a time. And what are the psychological issues that could manifest themselves?
Mm-hmm.
I assume, well, I know, but I don't know more than knowing that they do major psychological screenings of people before they even become astronauts.
Right.
Yeah. Right. They don't want a bunch of Fruit Loops up there.
Yeah. So, you want to apply to be one of the first people to set foot on Mars. You're going to need to prove to the people putting you out there that you are a sane human being and you're good at cooperating, you're good at problem solving. But sometimes you need a little more than that, because no human has ever done something like this. No human has ever put themselves in total isolation from the world for that long. And I remember when I took my graduate course called ISRU, Institute Resource Utilization, we were talking about people that were likely to do a Mars mission were going to practice. And what they do is they have these little camps, I guess, that are set up in the middle of a desert, someplace like Utah. And Utah even looks like Mars, added bonus. And they have this little house that the scientists live in for an extended period of time. And they track, what happens to them physically and mentally. So I'm gonna
I take a little exception to what you say. Like the people that go to Antarctica, they're stuck there together for 6 months at a time until the sun rises.
That's a good point. Right.
And there are other sorts of remote expeditions on our Earth that people do. But anyway, yeah, so it's like a biosphere thing.
Yeah.
It's very interesting because I had speaking of that, I had a patient a couple of years ago who had been going to Antarctica for a number of years, working, as a chef or something there. And, she had a lot more problems actually dealing with life when she lived here in Jackson, or, she actually organized better down in that environment. I mean,
wow.
She unraveled kind of here, and I couldn't believe she was going back, but that seemed to fit her for some reason.
Well, this pandemic has done that too.
True. Yeah. Lots of people who are really comfortable in their day-to-day jobs, interacting with new people every day and traveling, succumb to severe depression when they were locked down in their houses and working from home.
Yeah.
And, a lot of people suffered from this, and it became a well-known phenomenon.
Yeah, smaller number of people found it better than the real world, like my patient. But there was
I
a
do.
number, huh?
I do.
Well, there's what I was say. It's a
Yeah.
sizable percentage of, but it's a smaller percentage than the first group that Ryan is mentioning.
Right, right.
And that's a good point, Stuart, about Antarctica. I think I recall this like small documentary I listened to about, I can't remember if it was Ernest Shackleton or Douglas Mawson. I think it was Douglas Mawson. And he went through this unbelievable tribulation, hiking hundreds of miles alone in Antarctica, as close to death as possible. And when he finally reached back to the station, he was an absolute wreck. He was emaciated. Flesh was falling off of his face. He looked disfigured. It was the worst condition possible. What made it so terrible was that he had just missed the boat that was supposed to take him back to Australia. I think it was Australia. And the people who had to live with him and wait for the ship said he was an absolute lunatic. And so I can imagine what kind of severe consequences isolation would have for like a Mars trip if people become like that. I was just looking in this article, they have psychological studies of the factors that humans go through in order to figure out the best way to house this crew that's going to Mars. So I was just trying to look up to see if there were any results taken from people who had isolated themselves. Oh, here's a good one. When something goes wrong in the ship, let's say damage control, something, equipment malfunction. So that's one example. So imagine you're on that trip to Mars and maybe the second day you have equipment failure. If you're in a right mindset and you're sharp and you're focused, you can mend the problem pretty easily, pretty efficiently. Now, take that same crew 6, 7 months later, a year later, when they're, completely isolated for that long period of time, and then present them with the same exact issue, that same equipment malfunction. Is that problem going to be solved the same way, or is it going to be a disaster? So, something really simple, like, I don't know, a bolt came loose and you have to fix the door on that spaceship. That can become a catastrophe if people aren't in the right mindset and they freak out because, let's say, they're just mentally compromised. And this is what happened. When was it? I forget how many months it was. Okay, by the 5th year, that's it. The 5 years is when that isolation really started to get to them.
One of the things that wasn't clear to me was what was the connection of those 4 people? Because 2 of them, the last 2, they were living together. They were sleeping together. Now,
Right. Yeah. Lane and Miller. I think that was.
were they a couple before they went
No.
there?
No,
Yeah. It kind of
No.
formed as the trip went on, I think.
So that, and then what about the other two? Were they sleeping with each other, or we don't?
no,
They
no.
weren't.
One was a doctor, and the girl who died, I don't know what her job was. The what's the name of
Lisa Brown.
yeah. Yeah, that's the one who died. I don't know what her job was, but the woman who was sleeping with the captain was an engineer.
Mhm.
He was the Epps was the captain, Lane was the captain, she was the engineer, the Scottish bearded guy was the doctor, and yeah.
And it's crazy to think we have to study, psychological effects going to Mars, and these people are talking about doing a voyage that's taking several 10-year shifts.
That's awesome.
So this is taking multiple decades, and you wonder, like, how do we make that jump? A trip that's only lasting a few months to something that's going to last a few decades. And if there's even a way to study the psychological effects for that time.
Mhm.
But yeah, interesting thing to dive into. The second thing.
Well,
was,
before you leave there, I mean, again, I mean, it seems like I mean, how do you get a crew that would work for 10 years? And, the issues of sex becomes a big issue if you have a partner or you don't. And, that's part of the whole combination, trying to come up with a crew that's going to work.
Yeah, because that's not our human nature. We've evolved to be creatures that look for reasonable mating partners. And if you're putting these humans in a situation where they're going to just be alone and not interact with anybody else for pretty much their whole life, that is asking that's asking a lot. That's a huge endeavor. And, many people don't even stay at their regular job for that long. And now we're asking prospective astronauts to just travel time for 20, 30 years.
I mean, maybe it might turn out that in the end, the most stable team for something like that are couples already, 2 or 3 or 4 sets of couples where, you hope these issues don't come up between the couples, and all kinds of things, but it could become, it could get very complex. I know they use a lot when one of the speakers that Samuel had was talking about this trip to Mars and how they do a lot of gaming group theory and trying to come up with ideal ways of, there's a lot of issues. One is, how do you put a crew together, who they should be? But 2 is, what do you do with the ship and the activities and the physical environment to the extent that you have freedom, beyond the, the space, the physics requirements and mechanical requirements of the space.
Yeah.
How do you make it work? These are very, they're ongoing questions.
I think, and an idea that just came up was, maybe if you have a trip that's going to last several years and maybe decades, there may be a threshold where it's like, okay, you know what? Maybe we shouldn't have human beings making this trip, or live human beings. Maybe we should look to new technologies that like cryo sleeping or making the
Robotic.
ship, your robotics, yeah.
Oh, yeah.
Plenty of other alternatives to just having live humans stay on board for that long.
Although,
I think there should be a limit, though.
maybe, although it was we Americans that kind of couldn't handle it. I mean, it was like the third or fourth 10-year plan. The Chinese had just finished their 10 years, and it looked like there was another number of other countries that had their 10 years. The implication was they all did it.
Mm-hmm.
Yeah, you're right. I think it would be a hard thing. The other issue is, I just was reading it, but I guess it was there when you had that previous slide up. This was supposed to be a refueling station where ships went from Earth and they refueled on their way to Europa.
You're right. Yes.
So theoretically, they would have had a number of interactions, all those other crews.
That's true.
They
Yeah, they had to get to
years.
Europa 1 somehow.
Huh?
Yeah, they had to get to Europa 1 somehow. It says Earth's first space colony. So they had made the trip before.
Yeah, but I was saying I guess it's not clear to me whether, I mean, people had been obviously to Europa 1. So they stopped at Pangea on the way was the implication for.
Yeah, I see.
So they would have interaction then. I guess, the crew that did come with the European woman leader, they were planning to come anyway. They just, when Earth blew up, they left the ISS, which again, it's surprising that it still is around 170 years. But they left it early, but they were planning to come anyway and stop at that Pangea station. But in terms of dynamics, these crews would have had, these people there would have had interaction with a number of people theoretically in that 10-year period.
Yeah, but they were stationed there to man the station, right? Yeah.
And crews theoretically would have come there and repaired, just like this crew actually did, and then leave and go to Europa.
Yeah, and it was that that French astronaut aboard the ISS, when they had made that rendezvous. And interestingly, that was my very next point, which is, what is really the likelihood of two space stations, spacecraft, really anything, intersecting each other in the middle of the solar system?
Because it's a big place.
Yeah, is absolutely gargantuan. And to think that maybe they had some kind of tracker to have their location, but even then, I still don't know how that's done, how you can locate an object in the universe, like in the solar system. Because on Earth, you have satellites that do laps around the entire planet. It's not like you can have GPS in space, because you need something to orbit the entire solar system, which I don't think is feasible. So I want to dive in here and to give a sense of scale for the solar system. And this really cool website, one of my favorite things online in terms of astronomy, is the solar system to scale. And distance and size are preserved. So if the sun was actually this big, we can travel and see all of the other planets to scale. So here we are, and I'm just moving the cursor very little, and I've already covered 1 million kilometers. We could put it maybe in miles. Oh, you can get a lot of units. You can put them in AU, light minutes, pixels, Great Walls of China, and blue whales.
What about parsecs? They didn't do it in that.
Parsec, yeah, I'm surprised. They really should have that. I guess, well, parsec is 3 light years, so you'd be like 0.000 something.
Yeah.
But we'll do miles for now. So just a few clicks, and we're already at 1 million miles, and the sun is still pretty much right next to us. we would have to travel quite a bit. Let's see. Around about 36 million miles to get to Mercury. And look at the size of Mercury. It's literally a couple pixels in diameter. And, you know, this is a phenomenal distance. The other thing to keep in mind is we're traveling linearly. We're only going in one dimension. Space itself is 3 dimensions. So let's not forget that Mercury is going around in orbit, right? The sun. So the area of Mercury's orbit is something like, let's see, let's do 17 million squared times pi. We'll just probably type in 3. It's close enough. So we're talking 800 trillion square miles. Not 867 trillion square miles. And that's just the area circumscribed by the first planet Mercury. Just ridiculous. And I would do the
Although
volume.
don't most of our planets in the solar system stay on a fairly flat plane? I mean, it's not 100%. Everything
Right.
is.
Yes, the planets orbit the sun in relatively the same plane. But even still, it's easy to get lost in space. Like if you just maybe tilt your ship at half a degree over the course of millions and millions of miles, you could very easily miss your target by quite a margin.
Mhm.
Now, if we do the volume of Mercury's orbit, we're talking something like 5 sextillion cubic miles, which is just a number you can't even wrap your head around. Anyway, we'll keep going.
At the end of the movie, when he finds her in the other part of the station,
Mhm.
that to me is the greater, coincidence, miracle, whatever. Because did he even know which direction she went?
Right. Yeah. Same kind of puzzle. How you can have such a coincidence like that. Where
Yeah.
they just, happen to meet up in the middle of space. Like it's one thing for, imagine 2 planes flying in the air. And have you ever been on an airplane and you look out the window and you see one zooming by underneath you?
Yeah, very close, but it's meant to be a mile apart, but yes.
And that's
But it
a
looks
pretty
like
rare
it's next
occurrence.
door. Yeah.
Yeah, it's a pretty rare occurrence. And now we're talking about something orders of magnitude larger. So we passed Venus, we're at about 70 million miles. Then Earth comes in, just over 90 million miles. And look how far just the moon is from Earth.
So when they say they were a refueling station, because you don't use fuel once you leave the gravitational well of Earth, right?
Correct. You only need fuel to change your orbit around the sun. For example, this app lets me travel in one direction away from the sun.
Right.
In reality, that doesn't happen. All you're doing is just either expanding or shrinking your orbit around the sun, because you're always going to be pulled in toward the sun, no matter what.
Yeah.
To escape the sun's gravity, you're going to need an awful lot of energy. I don't think that's only 2 spacecrafts have done that so far. Both Voyagers
Yeah.
have essentially left the solar system.
Yeah.
They're on hyperbolic trajectories. Just take a look at, this is the last planet I'll get to. So Mars, you passed that 140 million miles. How much farther we have to travel to get to Jupiter? $250 million miles.
Who's there?
This is kind of going through the asteroid belt, but on this scale, asteroids are pretty much invisible. They're so tiny compared to the planets. And they're very spaced apart. In the asteroid belt, some diagrams, you should just see like a haze of asteroids. The average distance between any two, well, I guess the nearest two is maybe 1 million miles.
Oh, I was going to say, what are the chances of the asteroid belt coalescing into another planet?
Very, very slim. Although there is a huge, I guess we can call it asteroid or dwarf planet called Ceres that exists
Yes.
in between Mars and Jupiter. And that was, gravitational attraction of two lumps of rock.
Ah,
But we're still going after 400 million miles. It's now 4 times the distance away from Earth. It should be getting there soon. I think right about 500 million miles it should come up. Oh, there
There
it
we
is.
go.
485 million miles. And just the moons alone.
oh, you have the moons there.
Yep. Just the
Yeah.
4 largest.
Yeah.
The other 76 or so are so tiny they're invisible.
These are the Galileo moons.
Correct. Yep. And then, we can keep going to Saturn.
So where was where was Pangea with respect to Earth and Jupiter? Was it halfway-ish? Did they ever say?
I don't remember them specifying a distance to Europa 1, but assuming Europa 1 means the moon of Jupiter, then we're talking about the distance to Jupiter.
Yeah,
500 million miles.
yeah.
And then we gotta go way, way, way far just to get to Uranus. Almost 2 billion miles.
When I went to sleep.
Neptune,
Now we're killing them. Now it's 8 to
almost twice as far as that.
what are we with tonight?
3 billion miles.
It's in, 5th and now.
And then
Yeah.
Pluto is 3.7 billion miles away from the sun.
That it's a bigger distance than Nebraska.
Yeah.
Well, that's part of the rabbit hole that Carl Sagan went down when he said, what is it? It'd be a waste of a lot of space. There's a lot of space out there if we're the only ones.
Oh
Yeah.
yeah, truly is. And to remember, solar system is just a blip in the Milky Way galaxy. And so you kind of really appreciate whenever you see more sci-fi movies that have characters traveling across the galaxy. You have to really ask yourself, is this realistic? Can this actually be done? Space is quite empty.
Although on the other hand, we have more, I think it's atoms in our body than there are stars in the known universe for each one of us.
Right. Yeah. So those stars, even though they're plentiful, are so spread out that most of space is really just a void.
Mhm.
And that's not to mention there are actually things called voids in space. So I guess astronomy, yeah.
There's a Borg cube.
Right. So you can have 100 million mile cube, basically, or 100 million parsec. 100 million parsecs, so 300 million light years. That is thousands of Milky Ways in diameter with absolutely nothing. There's zero inside of it. And here's a map of where we think some of these voids are. And if they're really big, we call them super voids.
So
But yeah, look at this one, Booth void.
there was a recent map of dark matter.
Mhm.
So I wonder how that coincides with this map.
That's
with
a
the
really
overlays.
right. That's a really good connection. That dark matter may be associated with these gigantic voids. You
Because we
know,
just don't know enough that the
Right.
voids actually contain the dark matter.
yeah, we say that they're voids because we really can't observe anything that exists there. So we just throw our hands up and say there's nothing.
Yeah.
But the universe is not that easy to understand. There may not be anything such as nothing, complete nothing.
Yeah.
As we know, even in, let's say, a small box, if you evacuate all the air and you have theoretically pure vacuum, you still have virtual particles coming into existence and then annihilating each other. And these are called quantum fluctuations. Yeah, vacuum state fluctuation. So this is what we say is happening when a box has nothing in it. All the matter has been evacuated from it.
Well, it's interesting because I've read that book by that guy Wilczek. When 10 Keys to Reality, the one that just came out this year, that I told you guys about. And one thing I thought, if I got this right, if I understood it, is that he said that theoretically, the Big Bang, everything is going to be going out. There is homogeneity. There's no reason to think it wouldn't be homogeneous in all directions. So the question is, how do you even start with clumping of anything? It has to be non-homogeneity to get matter somehow. And it sounds like what he's saying is that the current theory has to do with exactly what you're just saying, that there's quantum fluctuations at some level that leads to this non-homogeneity at the beginning that allows for mass or gravity or anything at the very beginning to be non-homogeneous.
Yeah, what I've learned, or at least as much as I've understood, the reason that the universe is so homogeneous right now, and we'll just say in terms of energy, the temperature of the universe is about 3 Kelvin, and it's so incredibly uniform across everywhere we've mapped. And we're like, why is that? How could that be possible? Because there are places in different corners of the universe that have not had time to communicate to each other. And like one of the laws of thermodynamics says that if two things are the same temperature, they had to have come into equilibrium. Like, what are the chances that two things are just going to be exactly the same temperature if they've never even gotten into contact with one another?
Mhm.
The solution to it is say, oh, inflation happened. And so the universe, when it was, I guess, one single point, flew out so quickly that the universe that we see that's uniform everywhere is only one piece of that little, is only one little section of that huge inflation. And so we're only seeing a little corner. Our whole entire universe is just a little corner of this big balloon that had blown up after the Big Bang. And that's like one of the, I guess, theories of why we see this uniformity in temperature.
Yeah, I mean, I guess we can only know what we can know, and you're right. There's could well be a difference between the known universe and the universe.
Yeah, exactly. The actual universe.
Did you want to talk about any other headlines about the movie?
What about the issue of could Earth be blown up by, it was the old thing they pulled out. Well, it was the black holes created at the Large
At
Hadron
CERN.
Collider.
Oh, right.
And what were the other? What were any thoughts about the demise of Earth?
Yeah, I did think of that. Yeah, this is sort of like a myth that has been going around ever since the proposal to build the LHC. They're like, oh, don't build it because you're just going to destroy the Earth. And there are a lot of people going against the construction of CERN.
Right.
But I don't think we'll ever create a black hole here on Earth because the time scale on which these energies are achieved is so incredibly brief, it doesn't even matter. It's pretty insignificant. Okay, so here's a little thing about microscopic black holes. Yeah, they would disintegrate in about 10 to the minus 27 seconds. So
just
even
as an aside, I think that the lifetime of a Higgs boson is 10 to the minus 22 seconds. So this is 1/billionth.
Yeah.
As long as the Higgs boson.
Ephemeral. Yeah.
Mm-hmm. Yeah.
Cool.
So I would be on board with the engineers who were dismissing all of these people who were worrying and just be like, no, we're not going to create any black holes. There's nothing to worry about. And even if black holes were created, they're going to evaporate.
So what would be other ways? They just did it in like 10, 20 seconds. Other theories of how the Earth could.
Okay.
And the way they did it pictorially was that there was something internal, but when the Earth isn't structured that way, that would happen.
Yeah, hard to come up with really anything that would destroy the Earth from inside out. The last week we discussed about like the Earth's core and the radioactivity that goes on to keep it warm. Eventually it's going to run out of energy, it's going to cool off, but that's going to happen so far into the future that the sun will swallow the Earth before
long before
close to happening. Yeah. Earth could quantum tunnel. Earth could just literally vanish and poof into another part of the galaxy. But the probability of that happening is so inconceivably small. Let me see.
Of course, it could be hit by something, but that wasn't what was depicted.
Right. Rogue asteroid, I think, would be the most likely event to consider.
Yeah, they were talking about a comet at one point in the movie or
A
something.
comet would work. Yes, a comet probably wouldn't like blow up the Earth, but it would end all life. It's a very potential to end all life, yes. Blow the planet apart, like disintegrate it. It would have to be an enormous comet, something never before seen.
So even whatever hit the Earth to make the moon didn't disintegrate the Earth.
That's right. Yeah, Thea only busted out a fraction of its crust.
Yeah.
So yeah, you would need like another planet, maybe a rogue planet flying in to crush the Earth and disintegrate it, like actually blow it up. I don't think that's going to happen. I think if you could say destroy the Earth, if you mean end all life, and that could definitely be done by an asteroid or a comet.
Or Putin.
Yeah, or maybe World War III.
Yeah.
Or AI.
AI taking over the world. Yep.
Yeah.
Um,
Yeah. So I had another. Yeah. What is
go ahead.
quantum?
I'm just kind of like scrolling around. Go ahead.
Well, I was Stanford torus, the toroidal structure of an artificial world, is in. They talked about the donuts, the cylinder, the toruses creating gravity.
Right.
Yeah. So, those toruses on Pangea would have had to been huge.
Yeah.
Then
either make it really big or just make it accelerate really rapidly in order to simulate gravity.
yeah. Do we is this all theoretical?
I mean, yes, for now it is, but this works in practice. And for example, just using like a centrifuge to replicate weight, which is just a force. Well, force. We a couple weeks ago we were like, no, gravity really isn't a force, but I mean, you do
Right.
feel it. So
Yes.
for all intents and purposes, we can call gravity a force. When you get on that ride at the carnival and you stick to the wall, you're basically
Yeah.
experiencing pseudo gravity by
Right. That's
centrifugal
right.
force.
Right. Right.
And they do it in the training for the fighter pilots, and they put them in that machine.
Right.
they-
And for the astronauts.
They go dark. Yeah.
Yeah. Yeah. Yeah. There was a depiction of one in I think it's the first Star Trek movie of the new three movies, and you see a torus of skyscrapers and parks and living spaces.
I see.
Yeah,
Have to be very big.
Oh,
very
yeah.
big.
All right. In case you're curious, the
Yes.
probability of the entire planet quantum tunneling and, you know, moving somewhere else just like that would be somewhere on the order of 1/10⁻50.
So what is quantum tunneling? Is it like slipping into a wormhole?
Not really. Quantum tunneling is taking advantage of the uncertainty principle. This is really interesting because it happens in the sun all the time. Quantum tunneling actually happens in the sun, and that's the reason why it shines and we can see it. Because in the sun, we know that it's powered by nuclear fusion, and you have two protons, and they smash together and they form helium. But the sun isn't hot enough to fuse protons together. If you put protons in a 27 million degree furnace and under that much pressure, they wouldn't always fuse together because the electromagnetic repulsion would prevent them from doing that. Protons are both positively charged. The repulsion they experience is far greater than the momentum that they're being smacked together with. But there's a way around it. There's a slight chance, and I'm talking like 1/10⁻20 something, absurdly small probability that when the protons are close enough, they're like, oh, no, I'm actually over here. And that's just the weird things of quantum mechanics. You can actually be in two places at once, or a place where I'm not supposed to be. And so that's it. They're fused together because there was a probability that that proton was really connected to the other one and not this far apart. So quantum tunneling is like, just kidding, I'm not over here. I'm actually in this position. Gotcha. Because there's no way to tell for certain where this proton is and how fast it's moving. Now, you say, how does this happen all the time? How does the sun just keep on fusing hydrogen into helium? And it's because the sun is so big. It's so gargantuan that this little probability that protons actually fuse together, there's so many protons, this is like a regular basis thing. Protons just always form into helium because there's so many chances for it to happen that even that minuscule probability now becomes normal. It's quite a crazy thing when you read about it. This is just
and I guess in any given large area, there might only be a couple of protons in a million years that do this, but
exactly, yeah.
Again, between time as well as space, you're going to get enough of them doing that,
right,
to keep the process, the energy release going.
Exactly. If you have enough protons and enough interactions, you're
even though they're rare events.
Even though they're rare, because I have so many, I'm going to get quite a lot in actuality of fusions. I think it's one of the craziest things I've ever learned.
How long has that kind of been put together at this level of elegance about the sun? Is that like the last 5 years or the last 20 years?
Yeah, only a few decades, I imagine, because like the real advent of quantum mechanics didn't come around to the late 20th century.
Its applicability to many things. Yeah.
Oh yeah, totally.
Yep. Yeah, because I didn't, until I listened to it in this book on fundamentals, he was talking about that. I never heard of that, what you just described before.
Mm-hmm.
But it's wow. Yeah.
Right. And then the very final thing I wanted to touch on was, are there limits to how
One
much?
last question before.
Yeah, go ahead. Go ahead.
Is there? So what is the answer? In other words, if on Earth we have GPS with all the satellites going around,
Yeah.
you're implying that there's no way out in space that you can send beacons. There must be ways, right, to send beacons to each other to kind of
Some
hone
sort of
in
locations.
Yeah, location.
Yeah. I guess you could use like radio waves, and be like, okay, my radio wave was intercepted by this space station over here, but where is over here? How do I say it's at this angle from my ship and this far away? I mean, I could gauge
How about-
distance.
How about lasers? Lasers can be directed and, well, pinpoint, relatively speaking. Radio
Yeah,
waves
you would
don't
be
have
really-
any sphere.
The thing is, you would need a reference point. On Earth, it's really easy to locate distant stars millions of light years away because we have a horizon and a zenith, and we can tell, all right, it's like 45 degrees north, or in the direction north. But how would you do that in outer space when you don't really have reference points? You need to use distant stars to serve as a map. Basically.
Right, but if you're using distant stars and you're using 3 or 4 or 5 or 6, can't that, if you're using enough of them, can't that locate, a given point?
I guess you probably could. I think it's doable, but I wouldn't have the first guess on where to start.
Okay, so I got to leave in a
Probably
few.
like-
I got to leave in a few minutes. What's the punch? The bottom line on this last part, because that seems very interesting. What you're just bringing.
Okay,
up.
yeah. So it turns out there are limits to how much of the universe we can explore. And it all has to do with the expansion of the universe. Dark energy is actually preventing us from visiting any other galaxies aside from our local group.
Really? Why?
Even if we had all the power in the world,
Yeah.
traveling 99% the speed of light, whatever it is.
Because everything's moving away from each other. So
Yeah,
fast.
we can only visit tops 3 galaxies. That's it.
You couldn't visit. Isn't everything in the Virgo supercluster being held to some extent from this expansion, or is it only just the few galaxies you're talking?
It's really only the local group that's gravitationally bound. Virgo supercluster, all bets are off because gravity isn't that strong. But yeah, even if we had everything right and we could go as fast as possible and we had all the technology in the world, we can only visit maybe 3 or 4 galaxies in our local group. So we have the Milky Way. We can explore the outer edges of the Milky Way for however long we want. We can see Andromeda, and bonus,
Magellan.
it's coming toward us, so we can see that. That's fine. Triangulum, that's cool. And then maybe a couple of their satellite galaxies. The little
Magellan
dwarf-
Cloud or something, isn't it? Something called
Right, yeah, the Magellanic Cloud.
Magellan.
That's it, though. That's really it. So it's kind of a bummer that all these amazing galaxies that you see in Hubble Deep Field, we'll never ever get to see them. We'll never ever get to travel them.
Unless we get a new way of maybe it's not,
wormholes.
yeah, of not quantum tunneling, but wormholes. That
Yeah. So until we have wormholes, we're kind of stuck in our own local group.
Well, that's kind of sad. I mean, I guess it gets worse. It's that whole. I went through that thing that you showed us a couple of months ago. That 29-minute YouTube on the history of the universe. Woo!
Yeah.
That is depressing.
Right?
To watch that. But it's not that far in the future before. It's all black because everything is expanded.
Right. Yeah. And we're just starting
Mhm.
the whole universe's life.
Right.
We account like a septillionth of a percent
Right.
of the universe's timeline, which is
If
incredible.
that's true. I mean, it's kind of wow. Mhm.
Yeah.
Hmm.
I love that video.
It doesn't sound like it's a very most of the life of the universe does not sound very endearing to humanity.
No.
99.99999% of it, the way they put it.
Yeah.
We couldn't exist in.
But yeah, that's pretty much all the slides I had for today.
Well, that was great.
Yeah.
See you guys next week.
All right. Bye, Stuart.
Have a good one. See you, Deb.
Yes, next week. Yes. Okay. Bye. Thanks. Thanks, Ryan. Thanks, Stuart. Hello, Ann.
All right. I'll see you guys next Wednesday, and I'll post the video as soon as I have it up.
Yes. Yep. Okay. Toodaloo.
All right. Take care.
What do we do here? We do this. We do